we're asked to find the cube root of this number. Remember, a cube root means you're raising it to the 1/3 power. So we know what 8 to the 1/3 power is. It's cis 5 pi over 3. That's going to be tough. That's cosine 5 pi over 3 plus I sine 5 pi over 3. That's being raised to the 1/3 power. Okay, so 8 to the 1/3 power, that's 2. Taking care of a complex number being raised to the 1/3 power, the rule is when you're trying to raise a complex number in polar form to the 1/3 power, then theta is divided by n, where n is the root. So like we have a third root, so n equals 3 in this case. So let's take our theta of 5 pi over 3. That's what goes in here for theta. And now we need to divide it by n, divide it by 3 because it's the third root. So our angle theta is now going to be 5 pi over 9. So this is 2 cis 5 pi over 9. So we have an option there for that one. But just like in all things trigonometry, we have to consider all the other possible correct answers too. So if you remember, the period of sine cosine is 2 pi. So when we're taking the nth root, then when we try to find other possible angles that are also true for the cube root of this complex number, then we need to also consider everything that's plus 2 pi over 3 times k, where k is an integer. So basically what it means is, hey, we found an angle. We got 5 pi over 9. Another possible solution would be plus 2 pi over 3. And then another possible solution would be 5 pi over 9 plus 4 pi over 3. Because if k equals 1 for this one, if I let k equal 2, there's another possible solution. And if you simplify 5 pi over 9 plus, this is 6 pi over 9, so that's 11 pi over 9. Is that an option for an angle? Yep, that's the top one. And then over here, that's 12 pi over 9, so that's 17 pi over 9. That's an option. And then add another, do 5 pi over 9 plus 6 pi over 3. Because I just keep multiplying by k equals 1, k equals 2. Now I'm on k equals 3. So that's 18 pi over 9, which gives us 23 pi over 9. Looks like that's not an option. So that's probably it then, because we've used this rule for finding cube roots of a complex number. The other possible solutions are by taking 2 pi and dividing it by the nth root that you're trying to find. So if we're trying to find the square root of this complex number, then it's like raising everything to the 1/2 power. So we know what 9 to the 1/2 power is. That's, the square root of 9 is 3. And then remember the rule with angle theta. Theta is divided by the nth root. And since we're taking the square root, n equals 2. So we have 40 divided by 2, so our new angle is going to be 20. So 3 with cosine 20, I sine 20, this one works. We also want to find the other angles that work. So it has a period of 2 pi, but we need to divide that by the nth root, just like we did in the last problem. So we need to be able to add pi to this. Actually, sorry, this is in terms of degrees. So we need to be able to add 180 degrees. So 200 degrees would also be a solution. Okay, so find that first angle, and then you need to add 2 pi divided by n, where n is the nth root. You need to be able to add whatever this quantity is to your first angle, and that should be another possible solution. And then if we were to go again, add another 100. This turned out to be 180 degrees for our problem, so we got 200. If we add another 180 degrees, 380 would also work. But now that's about 360. Now we're just starting to repeat ourselves. That would be the same as this solution.